looking at today is composition of functions. So we're looking at f of g of x and g of f of x. So we're going to define the composition function h of x as g of f of x. Now, it doesn't say this in here, but one of the ways that we can write these are g of f of x, or f of g of x. And what they kind of call these, or kind of nickname these, are Goff and Fog. But it looks like FOG of x, Fog and Goff. These are our composition functions. Now, FOG of x is the same as f of g of x, and Goff is the same as g of f of x. Now, whenever we work with these functions, we always work from the inside out. So we always start with x and work our way out. Now, it's going to be a little more sense and make a little more sense as we look at these composition functions, actual application of these here. Now, the first step does seem a little bit weird, but it'll make sense as we do this here. So for any of these functions, so here I'm going to just rewrite this as f of g of x. We always start in the inside of this and work our way out. So we're always starting with x or whatever the number is instead of x. And the first thing we're going to do is we're going to take x and plug it into g of x. Well, if I plug x into g of x, what am I going to get? That's going to be what? X squared plus 3. Because what we did is we took every place there was an x in g of x, we replaced it with x. Well, is that really changing anything for g of x? Well, no, it's already in terms of x. So it doesn't change anything for g of x. So the first thing we did is we plugged x into g of x, which just really just gives us back x squared plus 3, because it's already been in terms of x. And what we do next is now we take this x squared plus 3 and plug it into f of x. So any place there's an x in f of x, we're going to replace it with x squared plus 3. So our x plus 2, well, the x is now x squared plus 3 plus 2. Because at f of x, this whole statement was our x. We'll replace it with our x squared plus 3. Any?
Why is it not x plus 2? Because you already have an x?
So here, because this is f of, because we had f of x would be equal to x plus 2, but we replaced x with x squared plus 3.
Okay, I'm with you.
And we get this here. So any questions on any of this so far? Yes? Okay, what we need to do is to simplify this here. Now, when we look at the x squared plus 3 in parentheses, well, there's nothing being multiplied. There's no squares. This is just x squared plus 3, yes? So we can drop the parentheses without changing anything. We need to combine like terms. We're just simplifying at this point. 3 plus 2 is plus 5. So f of g of x is x squared plus 5. Is x squared plus 5.
So, why did we have to write out all the f's and the g's? Because you just always just look x plus 2 and x squared plus 3, add them together, and get x squared plus 5.
Well, let's check it on the next one and see what happens. Because that's probably going to answer your question if we look at the next one. Because the next one we're going to do g of f of x. So we're going to go the other direction and see what happens. Now, I have a feeling that there are some questions on how we go from f of g of x to g of, or our first step where we simplified the g of x. That was a little bit confusing, like why did it just replace? Yes? Let me rewrite this a little bit. Let's just do f of g, or g of f of y, just so this makes a little bit more sense of what we're doing. Because this first part of plugging x into g of x, or f of x, doesn't make sense because it's already in terms of g. But if we do it in y, f of g, or g of f of y, well, here I'm taking y and plugging it into f of x, okay? Which means every place there's an x, we're now replacing it with a y, yes? So this here would be g of y plus 2. Because we're just replacing x with y, because we have g of y instead of g of x. Now, the reason it doesn't seem like we're doing a whole lot on the first one, where we took f of x first, well, every place there's an x, we're replacing it with an x, yes? So nothing changes. Here, we're doing the same thing. We're just replacing that term, y, with everything that had a x in the first place. Now we're going to do it again. But this time we're replacing y plus 2 into every spot where there's an x in g of x. We're plugging it into that function. Now what that's going to give us is y plus 2 squared plus 3. Because we took that term, because in g of x it is x squared plus 3. So we have g of y plus 2. We're taking this y plus 2 and replacing every x with it, which would give us y plus 2 squared plus 3. So we're having to replace that.
So why was the squared not last time?
Because of the order in which we went. Because last time we started with g of x, which was our x squared plus 3. And then we plugged the x squared plus 3 into...
So it's already squared.
Because here we're replacing the x with the x squared plus 3. So inside those parentheses, outside the parentheses, it wasn't squared. So the order in which we do this does have a little bit, it does matter. So any other questions on how we got to this step here? Well, we're going to have to simplify it, so we're going to have to take y plus 2 and multiply it by y plus 2, and then add 3 to it. Because we do have to simplify this down, we're going to have to multiply this out. Down a little bit. So when we multiply this out, we're going to have to distribute the y. Y times y would give us y squared. Y times 2 is going to be plus 2y. Then we have to distribute the 2. 2 times y is going to be plus 2y. 2 times 2 would give us plus 4 plus 3. And then last but not least, we'll need to combine like terms. Well, y squared is by itself. There's no other like terms with it. But our 2y and 2y would add together to be plus 4y, and then we would have plus 7. So our g of f of y would be y squared plus 4y plus 7, would be this here. And if we'd left it in terms of x, it would actually give it us the same thing. It would have just been x squared plus 4x plus 7. I wanted to use y so that you can kind of see that we're actually doing something in that first step. It's just hard to see it when it's in terms of x and everything's already given to us in terms of x. Does that kind of make sense on that there? So any questions on this here? On what we're doing with this here? Okay. We're going to do a few more of these here and seeing how this process works, because it's the same type of process. We're starting from inside and working our way out. We're always going to start from the inside side of it and work our way to the outside. F of g of x. F of g of x. So if we look at this here, we're going to start in the middle. We're going to plug x into g of x. Well, we already have what g of x is, yes? And what is g of x? Two x minus 4, because when we plug x into g of x, it is 2x minus 4. So any questions on this here thus far? Any questions on any of this here? Okay. So we plugged in x into g of x. So we always start inside. Now we have f of 2x minus 4. So we can plug this into our f of x. So in f of x, any place where there is an x, we're replacing it with 2x minus 4. So here we're going to have the cubed root of, since it has an x, we're replacing it with 2x minus 4 plus 1. So the only thing we're changing in our f of x is we're changing x to 2x minus 4. Any questions on how we got to this point here? Okay, now we just need to simplify this down. Because when we look at the parentheses, the 2x minus 4, nothing's really being applied to it. We don't have 2 times this set of parentheses. There's those negatives dealing with it. It's just by itself. So we can drop those and have 2x minus 4 plus 1. But if you, well, we can combine our like terms, which would give us 2x minus 3. So f of g of x is the cubed root of 2x minus 3. Any questions on any of this here? Any questions on anything we've done so far? Are we okay with this here so far? Yes? So really, we're starting off and we're taking a value and plugging it into g of x. And then what we get from g of x, we're taking it and plugging it into f of x. And once we simplify that down, that is our value of f of g of x, our composition function. Any questions on any of this here? All right. We're going to do another one, but we're going in the opposite direction. We're going to do g of f of x. G of f of x. We always work from the inside out. So the first thing we need to find is what we're going to have. So f of x, we're going to plug x into f of x. And if we do that, we get what? Well, the cubed root of x plus 1. Because really plugging x into f of x really doesn't change the function f of x. Now we're going to plug the cubed root of x plus 1 into g of x, which would give us what?
2x, or the cube root of 2x.
So we're going to plug that cubed root in, yes, into x. So any place where there's an x, we're going to replace it with the cubed root of x plus 1. So this x here is now going to be this. Mm-hmm.
did it backwards. I put 2x minus 4 where
In,
the x is x.
mm-hmm. Yep. And that works for g of f of x the other way around, yes.
So I'm putting the f of x
Mm-hmm.
with g of x, where the x in the g of x is supposed to go.
Yes. I'll do a write-out of how this makes sense here in a second, or how another way to think of this. Because luckily, we only have one more step with this. We just need to multiply the cubed root of x plus 1 by 2, yes? Now, because it doesn't have a radical, we're just multiplying it on the outside. It's going to be 2 times the cubed root of x plus 1 minus 4, and this here is g of f of x.
What's getting me is remembering which one to put, which one substitutes for which one, depending on if it's the g of x or the.
Yes. So let's actually look at that. Let's break this down. Let's say f of x equals 2x minus 6. So f of 2 would be what?
Would be 2 times 2
Minus 6. And we can work that out and get negative 2. Because 2 times 2 is 4. 4 minus 6 is negative 2. Yes? So we're good. We can wrap our head around this. Yes? Most of y'all say, doing this here, you're good. We know this. Why are we covering this again? Yes? So if we've got this down, okay, let's say f of house. How would we do this one? How would I write this? 2 times house. Because whatever is going in that spot is replacing it. And even with all of this here, where we have f of g of f of g of x, we always want to work from the inside out. So I'm not, whenever I look at these here, I'm not so focused on this yet. I always start here. And once I get whatever's inside, whatever's the farthest inside finished and simplified as far as I can, then I'll step 1 out. And once I get that as simplified as it gets, then I'll step 1 out. And we keep further going out from there. So, take that away. When we look at something like this here, this is the next one, where I have f of g of x. The first thing I always look at is the farthest inside, which would be g of x. And I want to get that as simplified as I can. So if we plug x into g of x, so we have f, our g of x is what? 3x plus 5, yes? So g of x, if I replace g of x, plugging x into g of x, we get what? 3x plus 5. Because that's what happens when we plug x into g of x, we get 3x plus 5. Any questions on this here? So 3x plus 5 is as simplified as it gets. We can't combine those because they're not like terms. So since this is as simplified as it gets, now we're going to focus on this one here, f of 3x plus 5. So we're going to be plugging 3x plus 5 into our x, which would give us what?
2 times 3x plus 5 plus 7.
Mm-hmm. Because we're replacing x with our 2x plus 5. Any questions on how this is working here, or what we're doing from one step to the next? Well, the last thing we need to do is we need to simplify this so we can distribute the 2. 2 times 3x is, 2 times 5 is plus 10 plus 7. F of g of x. Any questions on any of this here? Any questions on any of this here so far? Okay, we're good with this here. Let's do one more. This here will be the last type of this, last one of this type that we covered today. Then we'll move on to the next type. It's still dealing with these composition of functions. We're just changing it from x to something else. So again, we work from the inside out. So here we're starting out with f of x. We're going to plug x into f of x. And if I plug x into f of x, I get 2x plus 7. It really doesn't change as when we're plugging x into f of x. So we get g of 2x plus 7. But now we're plugging 2x plus 7 into g of x. Because now we're replacing x with 2x plus 7 for g of x. So any place there's an x in g of x, we're replacing it with 2x plus 7. So that would give us 3 times 2x plus 7 plus 5. So to simplify, we need to distribute the 3. 3 times 2x is 3 times 7 is going to give us 21, and we have plus 5. And 21 plus 5 gives us 26. So g of f of x is 6x plus 26. So any questions on this here? Okay. Yes. Okay. Now let's look at the other thing. This is the last thing we'll be covering, is this here. Now what's changing is that we're not actually looking at f of g of x. We're looking at f of g of 3. F of g of 3. And again, whenever we work with these, we're going to work from the inside out. Let's use a highlighter. So the first thing we're going to look at is g of 3, because I'm wanting to find out what is the value of g of 3. So we're going to plug 3 into our g of x. So in this here, wherever there's an x, I'm plugging in 3 for it. So that would give us what? 3 squared plus 2. Now on these here, at this point here, we can continue on and plug this into g of x or g of, or sorry, not g of x, f of x, f of 3 squared plus 2. But can we actually simplify 3 squared plus 2? Oh yeah, I can find out what 3 squared is. 3 squared is 9, yes? Because this is really the same as 9 plus 2, yes? Wait a minute, we can add 9 and 2, yes? So it's really saying that we have f of 11, yes? And on these here, when we have numbers, we want to simplify them down as far as possible because it's going to be a little bit easier to work with. Well, now what I'm going to do, I'm going to take f of 11. So I'm in f of x. Anywhere there's an x, I'm going to replace it with 11. So we're going to have what? 3 times 11 minus 4. Well, what is 3 times 11? 33. And 33 minus 4 is 29. No, minus 4. So I just wrote this up here on the whiteboard to show you kind of if we didn't simplify that down to 11, the 3 squared plus 2, we would get this here. Will this still give us 29? Well, yes. Because inside the parentheses, we're still going to get 11. It should be 33 minus 4, which will still give us 29. But here, there's a lot more going on, and it's a lot more complicated than we need it to be. So in each one of these steps, no matter if it's just x or a number, once we plug it in, simplify it down as far as we can. Then plug it into the next function, simplify, plug it in, simplify. Because it's going to make these easier to work with. Well, as soon as you can guess it, we're going to go the other direction. G of f of, this time, negative 1. G of f of and are always going to work from the inside out. Working from the inside out. So for this one here, what would we do first? Well, we're going to plug negative 1 into f of x. So anywhere there's an x in f of x, we're going to plug negative 1 in. So f of x is 3x minus 4. So it will become 3 times negative 1 minus 4. Well, at this point here, we could plug 3 times negative 1 minus 4 into the calculator, because those are all numbers, they will work just fine. Now, if we did it by hand, 3 times negative 1 would be negative 3. And well, negative 3 minus 4 is going to give us negative 7. The calculator would give us the same thing as well. So we could have done it in either way. Well, we're almost done now. We've got to plug negative 7 into g of x. So in every place where there's an x in g of x, we're going to plug in negative 7 for that value. So we would get negative 7 squared plus 2. Now, could we type parentheses negative 7 parentheses squared plus 2 into the calculator? Well, yes, the calculator can do that. And it would give us our answer. If we did it by hand, negative 7 squared, well, negative times a negative is a positive. And 7 times 7 would give us 49. And 49 plus 2 would give us 51. So g of f of negative 1 is 51. Any questions over any of this here? How do we feel with these here? We feel good with this? Yes? Do y'all want to see another example of one of these? No? You feel comfortable with these? Yes? Okay. Let's look at this here. This will be the last one we'll do. We're going to go a little bit different than what the note sheet says here. I use G in first hour, so let's use F this hour. Let's find F of 0. So doing this twice is not a restriction. We can do this more than twice. And we could flip between f and g of x. We could actually flip between 3 functions. It doesn't matter how many we have. We can do this multiple times. And again, the process that we do for this here is still always going to be going from inside out. F, F. Well, the first thing we're going to do is we're going to plug 0 into f of x. So any place where there is an x in 4x plus 7, it is going to become 0. So we're going to have 0, 4 times 0 plus 7. Well, what is 4 times 0? 0. So really all that we have left here is 7. Because 0 plus 7 is 7. All right, now we're going to do it again with f of 7. So we're going to plug 7 into f of x. Wherever there's an x, we're plugging in 7. So now we're going to have 4 times 7 plus 7. Well, 4 times 7 is 28. And 28 plus 7 gives us 35. Well, we're almost done. We've got to do this one more time. And this time we're plugging 35 in for x, which would give us 4 times 35 plus 7. So we're really just repeating the same process over and over and over again. So we can do this more than 2 times. We can do it as many times as we want. Now we need to do 4 times 35. 140. Because 35 and 35, 30 times 5 times 2 is 70. And if we double that again, we would get 140. And 140 plus 7 is 147. So this here would be f of 0. So you got to see here, doing this multiple times really doesn't make it any harder. It just makes it a little more tedious. We just have to repeat the process every single time. We're always working from the inside out. So are there any questions on this here? And that's it.